Hello, welcome to the session. In this session, we will be talking about application of integrals. In this particular session, we will be seeing how to find the area under the simple curves. Now let's get started. The first thing is seeing the concept. Imagine if there is a function y equal to fx and you have to find the area under that particular curve from the values of x a to b. In these kind of cases, imagine this is your function y equal to fx and you have to find this area which is below this curve from the value of x from a to b. In these kind of particular cases, you can apply the integral to find this. Hence, the application of integral, finding the area under the curve. How you can write is y equal to the limits from a to b, which are the values of x, and inside with the function which is basically this curve. You can write as y equal to integral a to b fx dx. Dx is the representation of this strip, and when we integrate it, it expands, covers complete area, which gives the value of the area after solving the integral. Now let's do a question to understand it more clearly. The question we have here is find the area under the curve y equal to x square for x values from 1 to 2. Now in these kind of cases, whenever you have a question, please remember that first plot it so that it will become pretty clear. Okay, here you can see the red color curve represents y equal to x square. The 2 points represents where x is 1 and y is 1, and at this point x is 2 and y is 4. Now we have to find the area over here, which is below this curve from this point, which represents where x equal to 1, the line, and this represents where x equal to 2, this line. Now how to apply integral on this? Let's first write the integral and simplify. The standard integral is y equal to a to b fx dx, replacing fx by the curve given, that is x square, replacing limits by the value of x, that is 1 and 2. Solving it is by the integration, that is x square integration, which is x cubed by 3 with the limits 2 to 1. Applying the limits, 1 by 3 comes out and x cube is basically over here is 2 cube minus 1. So this becomes 7. Solving it, the 7 by 3. Now we have to notice over here is one thing, that since it is the value of the area, we can write square unit. Okay, in most of the books when you solve, they might ask you to write the unit also, so just write square units because we have a standard kind of function over here. If it is given in the form of unit itself in the question, at that time you can add the unit as well. Otherwise, if they are asking just the value, you can write 7 by 3. Okay, now let's look at the other forms which falls under this category of application. That is, suppose you have a function which is given as x equal to gy. That means there is a function which is given in a form where it is in terms of y basically. So it can be like x equal to root y. Okay, now in these kind of cases, what you have to understand is the application will be similar. It's just that the area falls over here. That means it is on the y-axis and you have to take the limits of the y. So how you can write in these kind of cases? X equal to the value of y from where to where, you need to find the area, and then the curve itself, which is gy, and it will be represented as dy because this strip represents dy and the integration is in terms of y. The other form over here which you have to take care is when a function has area below and above. Now in these kind of cases, imagine, okay, this point is A, this is B, and this is C. Now if I have to write the equation for finding the area, these two, how you can do it? You can write total area as area below, above plus area below. Now in these kind of cases, please remember, above can be written directly in the form of integral from A to B, from the values, from where to where your curve is. Here we are supposing it's A to B. Plus, when you write below area, remember it should be in modulus, because when you solve the integral below or to any limits where the curve goes below the axis, it will give you a negative value. So at that time, please remember, it's very important, you have to take modulus, and the whatever value comes as negative, just change it to positive, because we cannot have area in negative. Okay, so do the modulus of this and then you can solve the complete integral. So I hope this clears your concept of application of integral having area under the simple curves. That's all for now. Thank you very much.